so now we're on the second day of 7.6. And our learning target today, now we're going to solve the logarithm equations. So solve logarithmic equations. And we're going to start out the same way we did in day 1 with the property of equality. And this one will be for logarithmic equations. Okay. So again, if we have the log and it has the same base, and we're just calling that b, and it's on both sides. So I don't know if I've used this term before, but this, whatever's in this position is called the argument. So if the base is the same, then we know that x has to equal y. Okay, so for example, if I had log base 3 of x equals log base 3 of 8. These have to be exactly the same if they're equal, so therefore x has to equal 8. Okay, so let's look at an example, a little bit harder example. Log base 7 of 6x minus 16 on one side of the equal sign, and again, we're trying to solve for x. And the directions will say solve. Okay. Alright, now both of them have log base 7, so the two arguments have to equal each other. And so you can, if you notice that it's on both sides of the equal sign, then you're just going to set these equal to each other and solve for x. Okay, so do your opposites to solve for x. So we find out that x equals 3. And again, you can always plug this back in and make sure that it works. Alright, now, so you're going to use this technique if you see the log, the word log, and the same base on both sides of the equal sign. Alright, so again, you have to have different techniques for different types of problems. So let's solve another one. Alright, now I don't have the word log on both sides on this one. So what I want to do this time, I need to get rid of the word log so I could solve this equation for x. And the first thing you're going to do is write it in exponential form. Remember, this is one of the first things you learned how to do when we started logarithms, is going from the logarithm form to the exponential form. And remember that we use the arrows. This is the base, and then the 2 will be our exponent, and then this is what it's going to equal. Okay, so we can write it in exponential form, and it would look like this. And then it's going to be easy to solve for x. Writing it in exponential form gets rid of the word log. Now the book does this a little bit differently, and they use the word exponentiate. And I don't do it that way, but you can look at that way and see if you like it better. It comes out, of course, to be the same answer. Alright, so x comes out to be 11, and again, anytime you want to check it, you can plug it back in and check it and make sure you're doing it right. Alright, and one more example. Now remember how you learn to condense, and so that comes in when you have the log expanded out, like in this example. Okay, so before we can do what we did here and write it in exponential form, we need to condense this part. So we're going to condense first. And so we have addition, so this is going to condense to multiplication of these two terms. Okay, after you condense, you're going to write it in exponential form. Now this one doesn't show a base number, but this is the common log. If it doesn't have a base number, we know it's 10. So we would have our base of 10, our exponent of 2, and this is what it will equal. So we'll have 10 squared. Okay, so we'll have 100, and then let's do the distributive property. 5x squared minus 5x. Alright, now we're going to get it set equal to 0. So I'm going to subtract over the 100. Alright, now we could use regrouping on this, but since all of these numbers are divisible by 5, let's divide everything by 5. Since I'm dividing everything by 5, it's not going to change our equation. Alright, so we have a quadratic, and we can either factor it or use the quadratic equation, but this time it will factor. So two numbers that multiply to be negative 20 and add to be negative 1 would be negative 5 and positive 4. So then we'll factor it. So we get two possible solutions, excuse me, for x. And now you have to be careful when you get a negative number, because if I plugged in negative 4 right here, I'd get the log of negative 20. And you can't take the log of a negative number, and that has to do with the asymptotes when you think about the graph. So anytime you would plug in a number and get a negative final number for the log, you know it's not going to work. So this one won't be a solution. This will be the only solution. Alright, so we basically had two techniques again. If you see the same log on both sides, then you can set the two arguments equal together. And then we can write it in exponential form to get rid of the log. And then sometimes, like the last example, we need to condense it first before we write it in exponential form. Alright, this is really important, and solving logarithm equations is really the goal of this chapter. Alright, that's the end of day 2.